Vector fields. A vector field F in R2 is an assignment of two-dimensional vector fxy to each point xy of a subset D of R2. The subset D is the domain of the vector field. A vector field in R3 is an assignment of a three-dimensional vector fxyz to each point xyz of a subset D of R3. The subset D is the domain of the vector field. Now, if you look below here, it says, for the following exercises, describe each vector field by drawing some of its vectors. So we're just going to draw some vectors here. So I'm just going to use a different notation for this right away. This equals x comma y. So, for instance, if I pick the point 1, 1, which is here, I'm going to plug in 1 for x and 1 for y. So I'm going to get the vector at that point, 1, 1. So that means I'm going to go to the right 1 and then up 1. And then my vector is going to end there. Now remember, a vector is just a directed line segment. So every point is going to have a directed line segment. So now if I pick the point, let's say 0, 1. So that point 0, 1 is going to be 0 for the x, 1 for the y. So it's going to go 0 in the x and 1 in the y. So it's going to just go up 1. And that's that vector. And then I can go to this vector here. This point here, and that's going to be negative 1, 1. So that's going to be the vector negative 1, 1. So that means from that point, I'm going to go to the left 1, because it's the x direction, and up 1. So it's going to put me here, and that's going to be my vector. And then if I do the point negative 1, 0, so that means I'm going to go to the left 1 and nowhere up or down. So it's going to be that way. I think I'm seeing what's going on here. I'm going to do a few more just to get the comfort level here. So if I pick negative 1, negative 1, that means I'm going to go down 1 and to the left 1. So that's going to be in that direction. And this point right here is going to put me down in this direction. That one in that direction, and that one in that direction. So it looks like we might be dealing with everything just going out from the origin. But we may not be certain, so let's try another point. So now if I pick 2, 1, it's going to give me the vector 2, 1. And that means I'm going to go to the right 2 and up 1. So even though it's going out, it looks like it's going to possibly topple over a little. And then if I go to 3, 1, that's going to be then here. At 3, 1, that's here. And that's going to be over 3 and up 1. So that's going to be in there. So as you see, it's starting to tilt to the right more as I go out. And let's go up a little higher now. Let's go 1, 2, 3. So we're going to do 1, 3, which is here. And that means I go 1 in the x and up 3. So that's going to be there. So that just kind of gives you a nice idea of what you're looking at. And look at all the vectors I actually had to draw for that one. I just kept going and going. And as you start to develop these, you can see the pattern that you can see with these vectors. So honestly, that's really what it comes down to. How many is enough? Good question. It's not really clear enough to predict what's going to happen with a whole XY plane. So this gives a good depiction of what you can see throughout. So this would be sufficient. Any loss? I don't know. Maybe.